Welcome to The Explainer. Today, we are pulling back the curtain on the silent conversations that power our digital world. You know, every time you browse a product online or place an order, there are dozens of tiny, independent services having this super fast conversation behind the scenes. And the rules of that conversation? Well, that's what we're here to talk about. It's the difference between a system that just works and one that can actually survive out in the wild.
Let's kick things off with this core idea. It's really easy to think of all this communication stuff as just plumbing, right? You're just connecting the pipes. But it's so much more than that. It's a strategic choice. It's a formal agreement that builds the trust and reliability of your entire system. And if you get this protocol wrong, believe me, the whole structure can come crashing down. So here's our game plan for today. We're going to start with why this is a flat-out survival requirement. Then we'll get into the digital handshake, the anatomy of an address, and the dictionary of actions we can use. After that, we'll unpack the critical difference between safety and side effects. And finally, we'll see how all these big ideas actually translate into real code. All right, let's dive right in. Section 1, a survival requirement. To really get this, you have to understand that for any modern microservice architecture, communication is not just some feature on a checklist. No way. It is an absolute survival strategy. Think about it. You've got a system built from dozens, maybe hundreds, of these little independent services. For them to work together and do anything useful, they have to have a shared language and some really clear rules. This communication framework, it's the connective tissue holding the whole thing together. It's like a global telephone network. I mean, imagine if every country used a different phone system and a different language with 0 translators. The whole thing would be completely useless, right? It's the exact same idea here. Without these standards, your services can't collaborate and the whole system just grinds to a halt. It's not a feature, it is the foundation. So if we're calling it a conversation, how does it actually start? Well, this isn't some casual chat. It's a formal, predictable digital handshake. And this process is what ensures every single request gets a clear and expected response. And at the heart of this handshake is a really clear power dynamic. On one side, you have the client. I want you to think of the client as a proactive customer walking into a store. They have a goal, right? They start the interaction. On the other side is the server, or reactive store clerk. Now, the server doesn't just shout random information into the store. No, it stands at the counter, listening, waiting for a customer to come up. And this is the crucial part. The server only speaks when it's spoken to. This relationship is absolutely fundamental to how the entire web works. And that interaction follows this really simple 3-step dance. First, the request. The client sends a carefully formatted message over to the server, basically saying, hey, I need this specific piece of information. Second, processing. The server gets that message, checks if it's legit, and then does the work. Maybe it looks something up in a database or runs a calculation. And finally, the response. The server packages up the result and sends it right back to the client. This 3-step cycle, request, processing, response, it's the fundamental heartbeat of pretty much all web communication. Okay, so for a client to actually find a server in this huge digital universe, it can't just shout into the void and hope for the best. Nope. It needs a precise, unique digital home address. And we call this a URL, or a Uniform Resource Locator. Every single part of this address has a very specific job. Let's break it down. First step, you've got the protocol, like HTTP. That defines the shared language, the rules of the conversation. Next, the host, like localhost. That's the server's location. You can think of it as the building where it lives. Then you have the port, which is the specific gate we're about to talk more about. And finally, the resource path. This tells the server exactly what we want, like asking for a specific book on a specific shelf in a giant library. Now, let's zoom in on the port for a second, because this concept is so important. If the host is the giant apartment building, the port is the specific apartment number. You see, a single server can be running dozens of different applications at the same time. The port is what guides the request to the correct gate for the right application. Without it, your message gets to the right building, but it has no idea which door to knock on. It is the final, crucial piece of the address. Okay, so we've got the address, we know how to find the server, but now we need to tell the server what we want to do. We don't just show up at the door, right? We arrive with a clear intention. And for that, we use a shared dictionary of action verbs. These 4 are the most common HTTP methods, and they're powerful because they clearly define our architectural intent. A GET request says, hey, I just want to read some data. Post says, I've got new data for you to create. Put is for updating or maybe replacing existing data. And delete, well, it's exactly what it sounds like. These verbs tell the server precisely how to handle our request and what kind of impact to expect.
Now, choosing between these verbs isn't just some technical detail or a developer's preference. No, it is a fundamental architectural decision about safety, about predictability, and about the state of your entire system. This choice has real consequences.
And this brings us to a core distinction in architecture. A GET request is considered safe. Think of it like browsing an online catalog. You can look at a product 100 times, and you're not changing anything on the server. A POST request, on the other hand, is designed to change the state of the server. This is like hitting submit on an order form. An action is taken, a new order gets created, and the system is now in a different state than it was before.
So that brings us to two words you are going to hear all the time in architecture: safe and idempotent. Now, they sound complex, but the idea behind them is absolutely key to building reliable systems. So let's just clarify exactly what we mean here.
A GET request is both safe and idempotent. Let's say you request the price of a book. You can send that same request once, or you can send it 1,000 times, and you will get the same price back every single time. And crucially, your repeated requests don't change the book's price on the server. The first request and the 1,000th have the exact same outcome. That predictability is what idempotent means, and it's a cornerstone of reliable design, especially when you're dealing with flaky networks that might cause retries. All right, now for something that might be a little bit counterintuitive. As developers, we're kind of trained to see errors as failures, right? But in a well-designed system, sometimes an error is actually a success story. It's a sign that your architecture is working exactly as it should.
A 400 bad request error, it's not a server crash. It's an architectural signal. It's the server acting like a smart gatekeeper. Imagine you try to post a new book with an ISBN that already exists. The server sees this, it recognizes it violates a core business rule, and it rejects the request. That 400 error is the server successfully protecting the system's data integrity. It stopped bad data from getting in. That's not a failure. That's a huge win for the architecture.
So, we've covered the why, the how, and the what. We get the strategy behind this whole language. Now for the big question, how do we turn all of these concepts into actual running code? And this is where the tools come in. In the Python world, a server framework like Flask is what lets us build that reactive store clerk we talked about, listening for requests at a specific address. And on the other side, a client library like requests gives us the tools to be that proactive customer, carefully crafting and sending those requests. These tools are the practical engines that turn all the architectural ideas we've discussed into real living code. So we'll end with a question for you to think about. Now that you understand this language, I want you to look at the systems you build and use every day. Which of those silent conversations, which hidden dependency between services is just one slow response away from a cascading failure? Because, understanding this language isn't just an academic exercise. It is the first and most critical step to building truly resilient systems. Thanks for watching.